folks, so today we are going to be looking at solving rational fractional exponent problems. Now, looking at this first problem, x to the 1/2 is the same as taking what root? Square root. Power divided by index. So these two equations actually mean the exact same thing. So we are going to solve them in a similar way where we are going to square both sides or power up both sides. But as we get into more complicated fractional exponents, we are going to have to think about some of our math spam rules. So the reason why I wanted to show the similarity is we are still going to have extraneous solutions that come up, different red flags that show up, and our solving strategies will be just a little bit different. Instead of isolating the radical first, we are going to isolate the base first. So let's go ahead and write those steps down here. Step 1, isolate the base associated with the fractional power. And then 2, power up. And 3, use your calculator to check. So looking at that first problem again, let's see if I can squeeze this on the same screen. Looking at that first problem again, we've got x to the 1/2 plus 6 equals 9. So I don't want you to rewrite this in radical form. I want you to work with the fractional exponent. So if I asked you to isolate the base, who's our base that has the fractional exponent? X. How will we isolate that? By subtracting 6 from both sides. So then x to the 1/2 equals 3. Now, if this still had the square root there, what would I power up by to get those to be the same? Or to get the radical to cancel out? We'd power up by 2. Instead of thinking about powering up by the index of the radical, instead we're going to try to get our power to be equal to 1, so that the fractions kind of cancel each other out. So the question you want to ask yourself is, what can I power up by so that when I multiply those powers together, 1/2 turns into 1? 2. So if I power up by 2 over 1, that would give me 2 over 2 or just 1. And if you're like, well, why do we need the power to be 1? Getting rid of that fractional power is the same as getting rid of that radical. So now I just have plain old x is equal to, ooh, is it 6 or is it 9?
It is 9.
It is 9. Very good. And before we put a box around it, we are going to plug in to check. So on your calculators, we're going to take 9 to the 1 divided by 2 power. And remember, older calculators, you will have to trap 1 divided by 2 in parentheses. And then arrow over to escape the exponent, plus 6, and boom, it is equal to 9. So our answer checks out from using our calculator. So we are all good to go there. Let's go ahead and take a look at B. First, we are going to isolate our base. So what's your gut telling you we should do first? Minus the 18. Move that chunk over to the other side, and we get 7. X to the 1/2 equals -6. Now, folks, is our base completely isolated? No. And maybe another question to think about is, who's getting that 1/2 power? Just the x. So I would want to divide this by 7 so that I get x to the 1/2 equals -6/7. So if x to the 1/2 is the square root of x, do we have any red flags on this problem? We do, because the square root of x is equal to a negative. So at this point, you actually wouldn't have to go any further, and you could just write no solution. But if we were to continue solving, what we would do is we would power up by what to make that 1/2 power into a 1? Power up by 2. So we power up by 2, and we get x is 36 over 49. Whoa, can I simplify that? No. The only factors of 49 are 7 and 7, so that is kind of my gross answer. But now we have to check it by plugging back in for x. So if we don't catch the red flag, we should be able to catch it when we plug back in. 18 plus 7 times 36 divided by 49 raised to the 1/2 power. And I get 24. 24 is not equal to 12. So if that would happen to me, I would probably go through and just double check my math one more time and make sure I didn't make a dumb mistake somewhere. But if you plug it in and it doesn't work out, that means this is extraneous. And our final answer is no solution. Let's go ahead and take a look at problem C. We look at the power that we have. Taking something to the 1/4 power is the same as taking what root of it? The 4th root. So what do you think we're going to power up by to get rid of that 4th root? By 4. So folks, let's go ahead and isolate our base first, which our base is this whole thing. So we're going to subtract 12. And we get 7x minus 2 raised to the 1/4 equals -5. Our root power is isolated. Do we have any red flags?
The negative.
The negative. So because this is equal to the 4th root of x, having the 4th root be equal to a negative is going to be a problem. So folks, in a general sense, if you have a square root or a 4th root equal to a negative, it is a red flag. What about a cube root? Can the cube root of something be equal to a negative? Yes, negatives come out of odd index roots as negatives. Negatives come out of even index roots as I. So there is no way for me to get a negative outside the square root or a 4th root, so that's why this one is automatically no solution. But if you don't catch it at the red flag, we can continue this problem. So we've got our base stuff isolated, and we would power up by 4 to get 1/4 times 4. Powering up, we multiply, would give me 1. So no more fractional exponent. And then -5 to the 4th would give me 625. Making sure that you trap it in parentheses when you try it on your calculator, because -5 times -5 would be positive, times another -5 is negative, times another -5 is positive. So then from here we would add 2. So 7x equals 627. Divide by 7. And we get 627 divided by 7. Math, enter, enter. And ooh, that's just going to stay that nasty fraction. So we take that nasty fraction, x equals 627 over 7. And then we would plug it back into our original expression, making sure we're plugging it in exactly as it's written. So I'm going to do the parentheses, then 7 times 627 divided by 7, and then minus 2. Raised to the 1 divided by 4 power. We'll do calculators again. Make sure you are using parentheses there. Plus 12. Ooh, not up with the exponent. Plus 12. And we get 17. So 17 is not equal to 7. We checked through our math. We did not mess up anywhere. So what does that mean about this? It is extraneous. And your final answer that you would write is no solution. Any questions so far? Last 2 problems. Last 2 problems of the chapter, guys. Woo! Let's go ahead and take a look at D. Now, this one's a little bit gross because we not only have a root power, we also have just a regular power. So if I think about twisting apart this power, this would be to the 1/3 power, or the cube root, and then raised to the 5th. I don't like either of those exponents, so we're going to try to get rid of those in one step. So I am going to power up. What can I power up by so that when I multiply 5/3 by something, we get 1?
3/5.
3/5. So we power up by the reciprocal. This gives me 5 times 3 is 15, 3 times 5 is 15, and 15 divided by 15 is 1. So you can power up by the reciprocal, and that will get you to a power of 1. And you'll notice it's actually what we've done on the previous problems. The reciprocal of 1/2 is 2, or 2/1. The reciprocal of 1/4 is 4. So when you have these more complicated powers, you can automatically power up by the reciprocal. So this would give me 4 minus 15x. And before you go reaching for the calculator, let's go ahead and do 1024 to the 1/5 power raised to the 3rd power. We go to our purple sheet or our yellow sheet. Is 1024 a perfect fifth? It is. The 5th root of 1024 is 4. So actually, I probably should have rewritten that as the 5th root of 1024 as an intermediate step. So the 5th root of 1024 is 4, and then 4 cubed is 64. So 4 minus 15x is 64. Next, we would subtract 4. So if negative 15x equals 60, what does x equal? Negative 4. Were there any red flags along the way? Kind of doesn't seem so. And our index of the root is odd, so there shouldn't be any issues here. But we're going to go ahead and plug it in to check because we want to make sure that this is correct. So parentheses 4 minus 15 times negative 4 raised to the 5/3 power. And boom, it does equal 1024. So our answer checks out. So we want to check our solutions to make sure that they are not extraneous, but also to make sure that they are accurate. So let's go ahead and look at problem E. What would I do to isolate the base first? We'd want to subtract the 18. So then bringing down that negative with the 2, negative 2x to the 3/2 equals negative 54. Am I going to power up yet, or do something else? So before we power up, we actually need to get rid of that negative 2 out in front. So we want to completely isolate that thing that has the power associated with it. So we'll divide by negative 2 first. X to the 3/2 equals positive 27. And what will we power up by so that the 3/2 power turns to 1? 2/3. We power up by the reciprocal. So those cancel. And I get x to the first, or just x. And before you go reaching for your calculator, 27 to the 2/3 is the same as 27 to the 1/3 raised to the 2nd. 27 to the 1/3 is the cube root of 27. This is practicing that calculator that non-calculator stuff from yesterday's homework quiz. Cube root of 27 is 3, and then 3 squared is 9. And I'll put an equals x on the end. We do need to check ourselves, and here's where our calculator comes into play. 18 minus 2 times 9 to the 3/2. And that is so bright. We see that that gives us a negative 36, which is what we wanted it to be equal to on the other side. So x equals 9 is indeed our solution. And congratulations, folks, because that marks the end of Unit 7. So what we are going to do next is start reviewing some of the stuff we did yesterday. I think we'll wait to do the homework quiz until tomorrow, so we will have kind of a chunk of work time today where you can start working on the additional homework problems assigned today and also on the Strength Finder activity. So in your homework packet, you can now do the remaining problems that we didn't circle yesterday. So now hashtag all, both on pages 3 and 4. And when is that due?
Tomorrow.
It's not due until tomorrow night, but folks, you will have the review packet to do tomorrow. So I would strive to try to get these problems done for tonight. So before we get into that, we're going to go ahead and review some of the problems that we did yesterday, starting on the back of the blue sheet. Because I know that some of the trickier ones, particularly the ones that bring quadratics into the mix, are a little bit tougher. So looking at this one, our radical is isolated. What are we going to power up by to get rid of a square root? Squared. So we're going to square both sides, or power up by 2. So p squared equals, the squared cancels out the square root, and we get 2 minus p. What should be going off in our brain right now when we see p squared? P squared makes this a quadratic. And what's our favorite way of solving quadratics? Huh?
Yes.
No, we don't love the quadratic formula. You can use the quadratic formula, but factoring is easier. So as a reminder, if you encounter a quadratic, you need to, which is any variable squared, x squared, p squared, whatnot, with also another x or a p with it. When we encounter a quadratic, we need the equation to be equal to 0 and then try to factor it. So if we need this equation to be equal to 0, do we want to move everybody over to the left or everybody over to the right?
Everybody over to the right.
Left. Why is the left only slightly better? We want to keep that square term positive. So it is less work to move the p squared, so you could do that and then multiply by -1, but keeping that a value positive is your best bet. So add the p, subtract the 2, equals 0. So now we factor. Product of -2, sum of 1, p plus 2, p minus 1. Set each of those equal to 0. We get p equals -2 and p equals +1. Are we going to put a box around both of those?
Not yet.
Not yet. Could both of them be solutions? Sure, but not necessarily. So let's start with -2. I plug -2 in, we get -2. Then I have 2 minus a -2, which is 4. Folks, is -2 equal to 2? No. So that one is extraneous. Because when we plugged it in, we got -2 equals 2, which is not true. Then we try 1. 2 minus 1 is 1. The square root of 1 is 1. Is 1 equal to 1? Yep. So one solution there. They might both work. Neither of them might work. And what happens if neither of them work? Then what's our answer? No solution. On your own, I want you to try number 2. So hopefully you were able to get to this point. If 45 scared you because it's kind of a big number, remember that strategy of dividing by integers until you find a pair that works. So we can divide 45 by 1 and 45. On my calculator, can I divide 45 by 2? Nope. But I can divide it by 3, which my calculator tells me is 3 and 15. We can divide 45 by 4. Nope. We can divide 45 by 5. And 5 and 9 get me positive 14. So if I need it to be negative, we can make both of those negative. So there are our factors. N minus 5 and n minus 9. So if n minus 5 equals 0, n is positive 5. And if n minus 9 equals 0, then n is positive 9. So negative 45 plus 14 times 5, plugging back into check, we get 25. Square root of 25 is 5. So 5 equals the n value I'm plugging in, or 5. So that works when we plug it back in. We plug in 9. So negative 45 plus 14 times 9 is that. Square root of 81 is 9. And 9 equals 9. So what's the dealio with this one? There really are two solutions. Two possibilities that make that true. That was not the lunch. Folks, any questions on that one? On checking, on solving, on plugging back in? Go ahead and try number 3. Why don't we get a square right away here? Because the radical isn't isolated. So we do need to subtract 4 first. Now when I square both sides to get rid of the square root, what do I have to do with the right side? FOIL. So because I have m minus 4 squared, that's m minus 4 times m minus 4. So, kind of a messier one here. So negative 3m plus 10 m squared minus 4m minus another 4m is a minus 8m plus 16. Now here's where students really go wrong on this problem. They go, hey, quadratic. Yeah, that is a quadratic. Well, I'm just going to factor it as m minus 4, and say that my solution is 4. Folks, why aren't we going to refactor what we just FOILed? What do I need to do first before I factor this? It has to be equal to 0 in order for me to solve and use the zero product property. So I'm going to have to move everybody over to one side. So 0, making sure you use the opposite signs to move them. M squared, negative 5m, plus 6. Oh, this one is evil. Try to factor this one. Careful with how you factor it. Got to have the right product number, got to have the right sum number. Why is it not negative 6 and positive 1?
Because the 6 will be negative.
Perfect. So they like to throw this one on the ACT just because it's easy for the brain to go one direction and do negative 6, 1 instead of negative 2, negative 3. That gives us the right sum number of negative 5 and the right product number of positive 6.
Wait, why isn't it negative 6?
Because negative 6 times positive 1 would give us a product of negative 6 instead of the positive 6. Yeah.
Oh, yeah.
So if we tried doing that, that would give us a negative 6 for the last term. So then m equals positive 2 and m equals positive 3. I want you guys to practice checking this one on your calculator. What's our answer for this one, folks? Try it on your calculator. Plug both of those in.
There's no answer.
Neither of these work. So if I plug in 2, that gives me -6 plus 10 is 4. Square root of 4 is 2. And 4 plus 2 is 6. 6 does not equal 2. So m equals 2 is out. If I plug in m equals 3, -3 times 3 is -9. -9 plus 10 is 1. Square root of 1 is 1. 4 plus 1 is 5. 5 does not equal 3. So neither of those answers work. So when they both end up being extraneous, the final answer is no solution. So be sure you write that on problems that have no solution. Any questions on that one? That was kind of a doozy. I think I'll save the other ones for after lunch, so use the remaining time to start working on the problems in your purple packet, page 3 and 4. Yes. Question?
I don't, like, where are we starting at
45. On the homework?
Yeah, like, cause it's like 3.
So folks, let's go ahead and take a look at number 45 on the homework. So in the purple packet. So the issue here is this, if we were to interpret this from a radical standpoint, would be the square root of 2x plus 5 cubed. Can I distribute that 4 into that radical? No. So we can't distribute it in. We divide it out. So get rid of that 4 by division. And we get 2x plus 5 raised to the 3/2 equals 64. So then, what are we going to power up by? 2/3. Power up by the reciprocal so that those will cancel out when you multiply those powers. That's what powering up has us do. And don't reach for the calculator here. Only use your calculator to check. If I want to find 64 to the 2/3, what is the root power? 1/3. And then the other power is squared. So then the cube root of 64 would be, going to our purple sheet, 64
4.
is a perfect cube. There we go. And the cube root would be 4. And then we square that, and we get 16. So 2x plus 5 equals 16. And folks, I would like you to show this work just to give you some more practice with that stuff we were doing a couple of days ago with not using our calculator. So go ahead and show that lovely work. So 2x is 11. X is 11/2 or 5.5. But we're not going to put a box around it. We're going to type this in on our calculator. 4 times parentheses 2 times 11/2 plus 5 raised to the 3/2 power.
Your answer key is missing the 1.
Does it just have 1/2 there? Should be 11/2. So sorry about that, folks. That should be 11/2 for that one. I will get that fixed on there. All right, folks. So you have the rest of the time until lunch to work.